Consider this problem statement. So it states that the sum of all possible solutions for this given equation, that is log of base 2x plus 3, and in the argument we have 6x square plus 23x plus 21, that is equal to 4 minus log of base 3x plus 7, and in the argument we are having 4x square plus 12x plus 9. This is k. So in that case we need to compute k first of all, and then finally we need to report the answer for absolute value of 24 times k, right? Now first of all, if you observe this argument, right, so we'll factorize this first of all. So on factorization this will yield 3x plus 7 times 2x plus 3, and similarly this particular argument, that is 4 times x square plus 12x plus 9, this one can be written as 2x plus 3 whole square, right? Now after factorization we'll go towards the simplification part, right? So first of all I'll write the given equation as it is. Now after this one I'll just use the factorized expressions. So instead of this 6x square plus 23x plus 21, I'll replace this quantity, right? In the similar way, this 2x plus 3 whole square, I'll replace this particular expression with this. Now I'll be applying the logarithmic property, that is whenever we have product inside the argument of log, so this distributes to addition, right? So product to summation. So this will be log of base 2x plus 3, and then we'll have this 3x plus 7 in the argument, and then on the other side after the summation this will be log, this will be this will be log base 2x plus 3, and in the argument again we are going to have 2x plus 3. Similarly if you observe this power 2, so this 2 will directly jump out here, so this will be minus 2 times log base 3x plus 7, and in the argument we'll have this 2x plus 3. Now once this resolution is done, so you can observe here this one, considering this logarithmic factor is defined actually, considering all the domain constraints. So based on when we follow all the domain constraints and all the rules of this logarithmic function, so considering all those rules we can replace this with 5. So whenever the base and the argument is same, it turns out to be 1, given the condition that here this algebraic expression, the x will be allowed only such values for which the logarithmic function remains defined. So based on that assumption I am writing 1 over here. Now here you can observe this log base 2x plus 3 and argument 3x plus 7, this one I can use the intermediate base property, that is natural log I will consider, and this argument will appear in the numerator. Similarly I will take natural log of this base of the log, right? Similarly similar to this we can also write this, that when we have log of base 3x plus 7 and argument 2x plus 3, right? So this can be written as natural log of the argument, that is 2x plus 3, and here natural log of the base, that is 3x plus 7. Now these is the split that I made over here, right? Now I will rewrite this equation using this modifications that I made over here. So instead of this one will be replaced with this quantity, right? So I'll replace it here. Similarly this 2 and this factor of 2 will be replaced with this particular quantity. Now on proceeding ahead, so what I'll do, I'll make some assumption over here. I'll say that let u represent this particular quantity, and this is representing this particular quantity, and considering that this this u and v is defined and the denominator never becomes 0. So here our assumption will be that when we write this, when we check for this denominator, that is log of 2x plus 3 and this natural log of 3x plus 7, this cannot be 0, because the denominator, if it becomes 0 then the quantity becomes undefined, and mathematically the system has to be defined, right? So from this we can write, this is our equation actually. So I will be rewriting this equation again, right? So instead of this one I can write this one as u by v, right? So instead of as my assumption is slightly wrong here actually. So instead of u, for u I'll consider this in my assumption, and for v I'll consider log 2x plus 3, right. Now here I will be writing u and here I will be writing v, sorry for that confusion. Now and here I will be writing v by u. Now considering that u and v should not be 0, because I do not want that my denominator goes to 0. So that is the implicit assumption over here. Now after resolving this particular equation, so you can observe here, this can be written as u square plus u times v is equal to 4 times uv minus 2v square. Now on resolving this equation further, we get u minus v times u minus 2 times v, that is equal to 0. So from this we can say that u will belong to this set. So first is v and the next root will be 2v. So here two different cases will be there, so we'll handle those cases separately, right. Now here the first case, so case when my u is equal to v. So in that case I will be writing that u is equal to v. This simply implies that natural log of 3x plus 7 is equal to natural log of 2x plus 3. So if that is the case, then by comparison we can easily figure out the value, that is 3x plus 7, which is equal to 2x plus 3, and from this we can clearly say that x will be negative 4, and this x equal to negative 4 has to be rejected because it will it will invalidate the domain, right. On substitution of this number, the logarithmic factor will get undefined, right. The logarithmic function will become undefined. So hence this x equal to negative 4 has to be rejected. Now the next case where my u is equal to 2 times v, right. So now I'll be solving this part, that is u is equal to 2v. Now this can be written as, so this one I can just copy this as it is, right, or maybe I'll just align this properly, right. So this is my given case and this will remain exactly as it is, only the thing is that these two will be written here, and in the next step I'll take this into the power of this one. Now on comparison, we can write this one as 3x plus 7, that is equal to 2x plus 3 whole square, right. So now on resolving this one, on resolving this quadratic equation, we'll be getting, so here x will belong to, one will be negative 2 and the other will be, other root will be minus 1/4. So these are the two roots. Now if you observe here again, so here x equal to minus 2 has to be rejected. Again, if I substitute this negative 2 in my logarithmic factor, so that will make my system undefined, right. But if you observe here negative 1 by 4, so if you substitute here negative 1 by 4 in this 3x plus 7, or you substitute in this one, right, so this argument remains positive, and hence we can say that 1 by 4 is the one which is acceptable value. So to say it technically, so we can say that as my this 2x plus 3, this has to be greater than 0. So from this we can say that x must be greater than negative 3 by 2, and indeed this for 2x plus 3 as well as for this other one, that is 3x plus 7, it will satisfy for both, right. So this is one thing, and also this is also a factor that we have to mention this clearly, that this particular quantity, that is 2x plus 3 is done. Now if I also talk about this 3x plus 7, also about this one also has to be greater than 0. So that means x must be greater than negative 7 by 3, and if you can observe this negative 1 by 4 is the only one which satisfies this. So therefore the acceptable value for x will be negative 1 by 4. negative 1 by 4, which is equal to k. So this problem statement mentions that the sum of all possible solution. The thing is that only one possible solution is there, so that is k itself, the single value, that is negative 1 by 4, and this is equal to k. But the ultimate answer, is on this expression, right? So based on this expression we need to evaluate, right? So 24, so it is in absolute value function, so k is negative 1 by 4, so this one is multiplied with negative 1 by 4, and hence the answer is 6, right? So for this problem statement 6 is the correct answer. So I hope the steps are clear to everyone.